Hi, I'm Laís Esperanza and I will present the Module 9 of the Integrate course about the use of life cycle assessment to analyze the sustainability of income. The module in this presentation is divided in 4 sections. First, I will introduce what is InterSystems and its sustainability issues. Next, what is the LCA, definition, methodology, and applications on the InterSystems. Then I will present a practical case of the Integrate project. And finally, you have access to the list of references and some suggested literature. Starting with the introduction. The Integrate Multitrophic Aquaculture, or INTA, is the enhanced production of aquatic organisms from 2 or more trophic groups, connected by nutrient flows that are fully or partially harvested to facilitate the ecological balance. And why you're doing that? We can start saying about the 17 goals defined by United Nations, that InterSystems would be able to address several of them, such as the zero hunger, the responsibility consumption and production, or life below water, but also indirectly many others, as good health and well-being, life on land, sustainability cities and communities, and many other ones. But when you are implementing a new system, we also need to think about the environmental impact that this can cause, not only the good things. For example, they have the emissions and the ecosystem interactions. So we need to understand how much the intersystem is really beneficial to the environment. And to do so, we need to assess the environmental impacts of the system. And we do that through life cycle assessment. So what is the life cycle assessment? Life cycle assessment is a method to evaluate the potential impacts, environmental and social, of a product or service through its entire supply chain. What means life cycle from obtaining the resource to final disposal after the usage. This methodology is already defined in several international standards as the ISO 14040 and 14044. And there are other several standards and supporting documents to define the methodology to apply the LCA, but not a specific detailed guideline to be applied to all scenarios. So there are a lot of variations in what to consider, and most of the published works are not comparable today. So we are going to use the methodology that is more used in defining the ISO, that is the methodology in 4 main stages. First, we go for the goal and scope definition, the inventory analysis, the impact assessment, and then you all pass through the interpretation in iterative work. And this can have direct applications for the product development, improvement, strategic planning, public policy making, marketing, and others. So starting with the goal and scope definition. We need to understand the intended application of this study, such as it is for a simple assessment or a comparison. The audience, what approach will you take, if the system boundaries, what data will you require, the functional unit, and allocation that will be used, as the impact can be assessed by mass, energy costs, or for the final product or a fraction of it, beside of all the assumptions and limitations of the design production system. So just to be clear, I'm going to try to give a little bit more detail on system boundaries and functional units, as it impacts directly in the INTA cases. So the system boundary. We need to set the criteria specifying which unit processes are part of the product system. So it's defining the start and finish point of the life cycle assessment. So you need to define the unit process to be included in the system, and you consider all the inputs and outputs as the elemental flows. So it can be from cradle to grave, cradle to cradle, cradle to gate, or well to gate, depending on what you're considering. The functional unit is the quantified performance of a product system for use as reference unit. So is the reference flow to which all the other flows in the LCA model are related. So usually it's your final product, but in case of the co-product, you need to allocate it, which one is going to be defined by which, and then it can be done by mass, energy, or cost. So all the results in the LCA are going to structure and be presented around the functional unit. So it is the basis for all the calculations. So for example, can be CO2 equivalent by ton of fish. So that would be your functional unit, or by kilojoule of energy production, or by amount of money that is sold. After the definition of the goal and scope, we need to collect the system data and make the lifecycle inventory. That is where we define what we should include as our inputs and outputs, and we quantify it. So the data should include the energy, material, all the other physical inputs and outputs, the product, co-product, waste, emissions, discharge to air, water, and soil, and any other environmental aspects. It's important to remember that the lifecycle inventory is an interactive process that would drive to the revision of goal and scope and data validation during the process. After collecting the direct data from your system, it's important to understand all the impact associated to it, and we usually use some international available database, such as ECVent, that is the most famous one, JRC, AgriBalize, and many others. These databases are important to understand the impact behind each input and output of the system, so he bring all the background for you. With the complete inventory modeling, we can start to make the impact assessment, where the results are presented divided by impact categories. So you need to select the impact category, the category indicator, and the characterization model. One example is the category, for example, climate change or global warming, that is indicated by greenhouse gas emissions using CO2 equivalent as characterization factor. So the data from the lifecycle inventory are used to calculate the impacts and to be presented in the impact assessment. As I say, the inventory results are translated to impacts that can be presented as midpoint or endpoints. When they are grouped to give more general impact numbers, such as grace to human health or natural environment and natural resource impact. The methods to normalize, group, and weight the impact categories can vary a lot, and there are more than 40 in the databases and literature nowadays, with some examples being the recipe, CML, or IPCC. So just to summarize here, it's not only about climate change. One example is the recipe. If you go for hierarchies midpoints, they have like 18 categories, including freshwater and marine and terrestrial toxicity, fossil and water depletion, agricultural land occupation, and any others. To help in these calculations, there are several softwares such as the OpenLCA, Gabi, CIMAPro. Each one has its advantages and disadvantages. While one has a better interface, the other gives more background details, the other one help in the modeling. Some are free, some are paid. So all is going to depend what you prefer to do. Then we go for the interpretation of the results to understand and check if the data, methods, and assumptions are correct and make sense. Doing that, we can face several challenges in the quality of the methodology, the data, considering the baseline, construction, correct location, and scale-up factor. To evaluate these challenges is required uncertainty analysis that evaluates the robustness of results, and it can be undertaken through varying the levels of various inputs and comparing these to the overall results, what shows the impact of various inputs of the process. There are several methods to do it, such as Monte Carlo simulation, sensitivity analysis, pedigree matrices, so it's up to you to choose which one is better. And to finalize the lifecycle assessment, there is a reporting phase where it's providing the interpretation of the results and its conclusion and recommendations. It's important to highlight that the report requires to show the relationship with the LCA results, a description of the data quality, the categories and points to be projected, the selection of the impact categories, the characterization models, the factors and environmental mechanisms, and the indicator results profile. We use the LCA methodology to evaluate the sustainability of INTA products and systems and assess more than only climate change impact, but several other impact categories, such as water, land use, eutrophication potential, and others. We also can use it as a comparative tool, rather than just straight up results, to compare that to the other systems and to identify environmental hotspots, strengths, and weaknesses, and then design more sustainable systems. For in the future, maybe we can have an environmental certification that is able to reflect the benefits of the systems when compared to single product aquaculture. So to exemplify it better, I will show how LCA is applied in the integrated project. In the integrate, we analyze three different scenarios that are the fishing polyculture, the semi-intensive and the semi-extensive INTA. The boundary was finishing the product harvesting, what represent the production of fish, oyster, and alga only, without the final packaging, transportation, selling, and consumption. The functional unit was 1 ton of aquatic product with the impact allocated by mass. And we use the EcoInvent database in the OpenLCA software and some recipe impact categories. So for the inventory, as input, we include the infrastructure and the equipment used, as well as the land used and all the consumables, such as water amount and its quality, the energy and the fossil fuels, the feed, including the composition and source, the chemicals, the fries, and any other product used as packages. In the output, we will have the product, the fish, oyster, algae, and any other, the wastes and the water discharge or any other emissions. So it's important to note that we need to make sure that we are considering all the metrics to help evaluate the sustainability and maybe to add in the future a certification able to assess the ecosystem service of this type of system. This kind of certification is to include the quality data of all inputs and outputs, effluent and feed characters, chemicals used, and any influence on the ecosystem as escapes and interactions. So I chose two results from the integrated project to exemplify the LCA analysis. We select 6 impact categories that are presented in XX, including the global warming potential, acidification potential, eutrophication potential, total cumulative energy demand, land competition, and water dependency. At the first graph, you can see that the comparison between the IMTA and the polyculture fish farming, where IMTA has less impact in all the categories. It's also possible to see the weight of each source of impact inside the categories. For example, the fish feed, that is the green one here, has the biggest impact in all categories, unless the eutrophication potential, where the rejects, that is the yellow, also stand out. This analysis is important to evaluate where we should concentrate our efforts to decrease the global impact. And the red one that also show up quite a lot here is the energy. This second graph, we compare the semi-intensive with the semi-extensive systems. And we see that more extensive is better because the internal flows of the feed are also encouraging the systems. Then, with this analysis, we can suggest where we should concentrate our efforts to improve the system. In the INTA case, 4 points can be stressed: the search for more sustainable feed, the diversification of products such as algae or sea cucumber and not only fish and oyster, the water recirculation where the system is separated in ponds, and renewable sources of energy and fuels. In conclusion, it's important to develop more standard methods and apply the LCA to more INTA systems. So we can create a universal model with specific background data and impact categories. In the future, we also should evaluate the ecosystem service of the systems with an eco label that would also help the market of the products, comparing that to the normal aquaculture product. So to close, I would like to leave a list of references that could help you go even further in the subject. So the ISO standards, some of the reference that I use in this presentation, and also some reference in LCA applying INTA systems. So thank you very much. If you have any questions, you can email me at lesperanza@greencolab.com. And I just would like to acknowledge the Integrate project that is funded by Interreg Atlantic Area Project, and especially IP Maceta Alga Plus and the Cerna that helped with the data and models, and also the Work Package 5 with WALG and Bancor University. So thank you all the project partners and funding body, and in any case, this is the contact channels for the project. I hope this presentation was useful. Thank you very much.